Investigation of operation of heat sensor located on the ceiling. The authors are Svetlin Antonov and Kamen Grozdanov, Technical University of Sofia. The operation of heat sensors located on the ceiling of the room in case of fire is investigated. The method for determining the temperature for impact on the sensing elements of the sensor is given. A method for calculating the time for activating the temperature sensors depending on their location has been obtained. The main factors that affect the temperature distribution on the ceiling of the burning room are the intensity of fire, the height of the ceiling, and the distance of the sensors from the axis of the torch. When the flame torch reaches the ceiling of the room, a semi-limited flat jet is formed on it. It spreads evenly in all directions on the surface. A number of studies, both experimental and theoretical, have studied the propagation of a flat limited jet. For the most of them, the examinations are made with the jet flowing in a simultaneously concomitant current in a limited space. This is an isothermal model of the spread of a torch on the ceiling. In this case, a concomitant current caused by the semi-limited jet arises, and this makes the model very close to the considered problem. It is necessary to calculate the heat transfer to the sensing element of the sensor, which means to use the distribution of the maximum temperature at the corresponding point of the section. The maximum value of the temperature in the area of adhesion to the ceiling at its height above the floor of the room is determined at a certain distance from the axis of the jet on the ceiling. Lower of the thickness of the jet when the torch adheres to the ceiling of the room. The figure shows the spread of the flame torch on the ceiling for the thickness of the boundary layer. When adhering to the ceiling is assumed that R is equal to 0.22. At a certain distance from the axis of the jet on the ceiling for R greater than R0, outside the area adhesion, for the maximum temperature differences, the expression is recommended. The case of a fire that develops near the walls or in a corner of the room, its temperature is significantly higher. This is due to the limited space from the ceiling and the occurrence of a wall jet. The minimum intensity of the fire that will lead to the activation of the heat sensor is determined by the condition. The equations are processed for the minimum fire power as follows: at a certain distance from the axis of the jet on the ceiling, lower of the thickness of the jet when the torch adheres to the ceiling of the room, and at a certain distance from the axis of the jet on the ceiling, greater of the thickness of the jet when the torch adheres to the ceiling of the room. The specific heat flux is determined by the expression where lambda is the heat transfer coefficient. The response time of the sensing element is determined by the expression where alpha sensor is the heat absorption coefficient of the sensing element. The graphic shows how the maximum temperature changes in height for two different distances away from the jet axis. The presented method is recommended to be taken in case of stationary poorly developing fire. In addition to the conclusions, do not introduce the restrictive conditions regarding the dimensions of the ceiling panel. It is presumed to be unlimited. The maximum temperature of the ceiling in the area of adhesion of the torch to it is given. Decreasing the height of the room and increasing the power of the fire causes an increase in the maximum temperature. The change of the maximum temperature moving away from the adhesion zone is illustrated as follows. Moving away from the point of attachment of the torch to the ceiling at the full height of the room leads to a reduction of the maximum temperature for a given section. At certain conditions, as R is greater than 1 meter and H is greater than 8 meters, there is a real possibility to actuate the sensors. The time for activation of the temperature sensors located on the ceiling can be calculated much more easily. According to the given dependencies for determining the maximum temperature at the ceiling as a function of the height and power of the fire, the time for activation of the fire sensors is calculated. The response time of the sensor is determined by the dependence. And the next three figures are given the changes of time for the torch to reach the ceiling for the fire power up to 300 kilowatt, up to 1500 kilowatt, and up to 3000 kilowatt. The influence of the two main initial parameters is obvious from the figures: the power of the fire and the height. The power of the fire shortens the activation time of the temperature sensors. The same can be said for the height. The presented method for calculating the time and required temperature for activation of the heat sensors allows a quick analysis in their design and possible expertise after a fire. The main parameters required to apply this method are the power of the fire and the size of the room in which the fire is developed. The authors thank for your time.